So we have this minimum operations to half array sum, and it came yesterday in biweekly. It was a C question, I guess. Yep. So what we are provided with, we are provided with an array, and they have asked that in a return minimum number of operation to reduce the sum of this array by at least half. By at least half mean it should be less than half. And what we can do, we can reduce each number, choose any number from now, and we can reduce it exactly to half of that number, which means we can just half number we can just slash it by 2. That is the operation we are allowed to do. Note that you may choose this reduce number in further operation, which means if you'll slash it, you need to keep it into the array. You cannot just whoosh it. I'll show you the example. For example, if I'll pick this, and this is my 5, 19, 8, and 1. So the total sum will be 20 and 8. This will be 33. So I should divide this by 2, and it will give me 16.5. So whatever I do with this array, I have to compute the minimum operation to make sum of this array sum of this array less than 16.5, less than 16.5. It can be 16.49 because float values are allowed, but it cannot be greater than 16.5. Okay, so we'll jump onto the solution directly. The approach which I thought initially was, I'll be using the priority queue, and this definitely worked. I'll tell you how. We'll be using priority queue. Why? Because I saw a pattern. I saw a pattern that every time, and that pattern I picked actually from this question only. What I saw is the explanation they gave me. Initially, they took the largest number. They took 19 because 19 was largest. A basic. I'll just give you a very basic intuition. You are provided with some rocks of different size, and you are asked to decrease the weight. To decrease the maximum weight. So what will you do? You'll take the maximum stone, stone with maximum size, and you'll just slash it by 2. You'll just cut it down because, for example, this is a 10 kg of stone, and this is a 1 kg of stone. So slashing this by 2 will make it 5 kg, and this will make the significant difference of 5 kg. But slashing this will only make a difference of 0.5 kg. So that's what I saw here, that they took the largest number, they slashed it into half. Then again, they inserted this number. This number was actually inserted in this. It's not like that you have taken the number and you'll delete it. You cannot delete it basically. 5, if you slash 19 by 2, you need to keep this 9.1 into our array. Then again, what is the largest element? So that's how I picked the intuition. Largest element was 9.5 again, so we slashed it. Then largest was 8, and we slashed it. And we were keeping the sum all the time. So there is a trick in that also, I'll tell you. And the final array was this, which total sum was 14.7.5. Okay, and sum was also reduced by this. So it is, and overall 3 operation was used, so we return 3, and it cannot be done in lesser than 3. So 3 is the minimum operation. So what is the intuition? So the intuition I have already told you, that we'll take the maximum number every time. We'll slash it by 2. We'll slash it by 2, and we'll keep updating our sum. We'll keep updating our sum. So definitely we'll be needing a while loop while our sum is greater than, or what I can do, while our sum is greater than our hold. Hold is threshold value basically. Hold value is threshold value, which will be equals to, in this case, 33 by 2, that is 16.5. So while our sum is greater than 16.5, we'll just make the we'll continue for that only. Otherwise we'll just come out. Once your sum drops down 16.5, you need not to check anything, or you need not to do any variation. So what we'll do, we'll take the maximum number each time and we'll keep slashing it by 2, and we'll keep checking our sum. So we'll not be computing our sum again and again. What we'll be doing, we'll be using intelligent maths by subtracting that number. I'll tell you how. I'll do the intuition here, and you'll get the idea. So 5, 19, 8, and 1 makes 33. Okay, now I have slashed this 19 in 19.5, so I have the new array. This is my new array. Now my sum should also be slashed by 9.5 now. From my sum, I'll give you another stone intuition. These are my stones. Okay, the weight was initially 10 kg of this stone, okay, and I broke it into half. So now its current weight is 5 kg. So in overall stone weight, I also need to decrease the 5 kg weight now because I have destroyed that 5 kg weight. That's why, let me just, yep. That's why when we change this thing, we need to update our sum also. So for example, this is our array and it has a sum x. Now what I have done, I have taken 10 out of it. I have taken 10 out of it. So I need to take 10 out from my RHS also. That's when they'll be equal, na? Very basic intuition. So when I changed 19 to 19.5, then I have to subtract this 9.5 from 33 also. I need to subtract it. So what will happen if I'll subtract? It will be, I guess, 22.5 if I'm not wrong. 22, no, 23.5. It should be 23.5. Yes, it will be 23.5. Let me just check. 5501. Ha, it will be 23.5. So I'll just erase this mess. So my new sum will be 23.5. But in our condition, in our while condition, we have already said that if sum is greater than 16.5, 16.5 is threshold value. If the number is greater, then keep computing, keep computing. And what we are computing, we are just slashing the largest bit. So we'll take the largest number again, 9.5, we'll slash it by 2. This will be 4.25 this time, okay? And we'll put it back, 4.25 and 8 and comma 1. So we'll again subtract from the sum. This is 23.5. We have already taken out 4.25. So we'll subtract from it. 4.25 will be subtracted. This will be 4294 something something. I don't know what will come. This will be again 23. Why I am so weak at maths? Fuck this. 20. We'll just we'll just do it manually. This is 23.5 and we need to subtract 4.25. So 4 subtracted from this will be 19.5 something and 2 subtracted will be 19.25 something. Okay, 19.25 will come. Now there will be 10. This 19.25 is still greater than sum. Is still greater than our threshold value. So we'll keep going. We'll keep going for another iteration. Another iteration will take the highest number from biggest or largest. You can say anything. Highest number from array will chop it down to half. Now our new array is 4.25, 4 and 1. Now we'll subtract 4. Now we'll subtract 4 from this. If we'll subtract 4, this will be 12.5, which is definitely smaller than 16.5, and our loop will just end. So I'll show you the code. What we have done, we have declared this double thing. Okay, this is our sum and we have declared a priority queue. So priority queue, the advantages of priority queue is that you remember we need to do 3 operations every time we need max of our array. So instead of finding max every time, we just kept a max priority queue, max heap priority queue, which will be providing on top. Like if you write p top, so this will provide sorry, this will provide you with the max value. Okay, priority queue. Then also then one more thing, when we were slashing, when we slashed 8 or when we slashed 19 by 2, instead of taking out that number, I'll show you here. When we were slashing it, instead of taking it out, instead of deleting it and then again adding it, what we were doing, uh, yeah, sorry, what we were doing, we were just subtracting the actual number which was deleted from it, which were deleted. I'll show you how. This rock example I'll take. So I've already told you that if this is a bigger rock, these are the smaller rocks, and if the sum is x and you have subtracted 5, you have destroyed half of the rock. So x minus 5 will be there. So instead of if this was 5, 8, 11, instead of taking this number out, then making it half, which will be 9.5, and then inserting it again, this will take lot of time. So instead of doing that, what we can do, we can just directly keep that number there and we can just subtract the sum which we are destroying basically. So we'll jump back to the solution. Yep. One more thing, I have used this stupid accumulate STL for computing my sum, and this will give you overflow 110% for greater values. This will give overflow definitely. So I would recommend that instead of doing that, you can just do it manually. Okay, just do it manually. Just take out the sum of your array manually. Now I have taken out the sum, and this is my priority queue, which is in double, and I've already arranged my array, my provided array, into my priority queue, which is a max heap. Now what I'm doing the same thing. If my p is not empty, and if my sum is greater than my threshold, which was if my uh, कहाँ पे गया? Just a second. Where it is? I have written here somewhere. If my sum is greater than hold, na. Where is my while condition? Just a second. I might have erased. Yeah. While sum is greater than 16.5. So while sum is greater than our hold, it will continue to move. What we are doing, we are taking our top. We are taking the maximum value from element. So we are taking 19, and we'll pop it. Okay, we'll just delete it. I'll tell you why. Because you cannot, what I've told you here, na, what I've told you here, that you will not delete it and then you will not add it. This is for the sum thing. Like this is for sum. For example, I've given you this rock example. What will happen if we'll not delete it, na? I'll show you here this thing. If we'll not delete it, what will happen eventually? You need to change it in place, which will be very difficult. So instead of changing it in place, we'll just take it out and we'll put it back again. Here, what I was told, here what I was talking was related to something. uh, this is getting creep. This is getting messy in the end. Just leave it. Just understand that we'll take it out. We'll take the top. We'll pop it. We'll increase the count because this count is the answer that we needed. And what we'll do, we'll subtract our sum with the value which we have taken out. This value divided by 2. Basically, we took out the 19, which was the biggest element, 19 by 2. It became 9.5. So 9.5 value is destroyed from our rocks. So this 9.45 value will be subtracted from our sum, and again the value which is remaining 19 by 2, this value 9.5 will be inserted back again into our array and will return the count. So if I'll just run it now, it will work and it will get submitted also. It's working, but you know the space and time complexity is quite high. So that was it for